In this video, we're going to start looking at volumes of different types of prisms. To begin with, we're going to look at cubes and cuboids. This should be revision from first and second year. This should not take you very long to sort of revise and pick back up. We've got volume of cube or cuboid. So a cube is basically, it looks like a 3D, what a lot of students describe as a 3D square. Things like dice tend to be cubes, so every single side or every single edge is the same length. In cuboids, we've kind of dealing with more kind of box shapes. So things like cereal packets and books, that sort of thing, they're all sort of cardboard boxes. They all tend to be sort of a cuboid shape. Now, the formula that you guys were supposed to remember from back then was volume is equal to length times breadth times height. So that's your length, there's your breadth, and there's your height. Now, obviously, I could rotate this, and your length, breadth, and height are still going to be the same. Because the three numbers are timesing each other, it doesn't matter which order you decide to go and multiply them in. I just have allocated which one's which. Okay? So in this, we should be able to just say, well, length is 3, breadth is 2, and the height is 8. We know that 3 times 2 is 6. So 6 times 8 gives you 48. Now, this is where your units come in. Remember, we looked at that in the last video. We've got centimetres, centimetres, centimetres. So it's going to be centimetres. Because we're dealing with volume, though, remember that we have to put the little 3 up there. So the volume of this cuboid, length times breadth times height, gives us 48 cubic centimetres. In this one here, we have a triangular prism, things like Toblerone bars and so on. Whoops, drop my ruler. Toblerone bars we have as a triangular prism. I'm sure that you can think of other things, maybe like tents, might be set up in a similar way. Maybe not quite as slanted as this triangular prism, but it still works. Now, the area for this one tends to be either length times breadth times height, then divide it by 2, or half the base times the height times the length. I know that it does look like the same thing here, but there is a subtle difference. Whenever I'm dealing with anything that looks like this, what I tend to find is in different problems, we're given what the base is, and everyone's quite happy with that. Let's say that's 10 centimetres here. But then a lot of folk think that that side there must therefore be the height. Now, if you think about the height of yourself, the height of you is when you are at right angles to the ground. So it's from you going from here up to the top. As soon as you start leaning over, you are no longer at the maximum height that you could be. So your height doesn't vary at any point. It's just how far your head is from the ground, which is a bit that varies. So what we actually need is distance going from here straight up to the top. We notice that, well, if I pick my ruler up and do this properly, we'll see that it's certainly a lot straighter than that line there is, okay? Well, I'll say straighter. It's definitely a different angle to how that one is, okay? So that's 10. Let's say this is 15 centimetres going this way, and let's say that this length of our tent is going to be, or box, or whatever it might be, is, I don't know, 20 centimetres, okay? So area, and this is going to be half the base times the height, then times by the length, okay? Well, the base is 10, so half of 10, our height is 15, times 20. Well, half of 10 is 5. 5 15s are going to give us 75. Times that by 20. 75 times 10 is 750, so 1,500 centimetres cubed. All right? Now, so far you'll noticed, I'm hoping you've noticed, L times B, we know that the area of a rectangle, or a square in that case, is length times breadth. All of those just times up by the height. This one here, half base times height times your length, just have to use a different letter. Half base times height is your, and why have I put A here? This should be volume. Sorry guys, volume. Half base times height is your area of a triangle. So area of a triangle, from the basic principles that you had to do, was a half the base times the height. So all we're doing is finding the area of the end shape and then timesing it by either height or the length, depending on what you would call that bit going back the way. So again, the area of this triangle we worked out first, half of 10 times 15, that's that triangle there, times by that length there. Well, that makes life a little bit easier when it comes to alternative shapes, like this cylinder here. Because a cylinder is just basically, it's a circular prism. Whereas the ones before, we had a triangular prism, we had a rectangular prism, or a cuboid. Here we've got a circular prism, a cylinder. So we know that the area of the circle that's on the end is equal to pi times the radius squared. Or at least we should know that by now. And remember, the radius goes from the middle out to the edge. That's your radius. Now, if we follow the same principles, then the volume is going to be pi times your radius squared times, let's just call that the height. So pi r squared h. If we want to take out all the times signs and use algebra correctly. And certainly if you're looking up online, that is the formula that will come up for volume of a cylinder. So let's say we're told that this is 3 centimeters. So volume equals pi times 3 squared times, let's make that 10. 10 centimeters go that way. So times by 10. Now, normally I'd be asking you to use the pi button on your calculator, and I've not got my calculator with me. So just give me 2 seconds. Let's assume that this is 3.14. I'm going to times that one by 3 squared is 9. And if it's a non-calculator, they will actually ask you to use 3.14 instead. If it's not, and you've given your calculator, please use the pi button instead. 9 times 4 we know is 36. 9 ones are 9 plus 3 is 12. 9 3 is 27 plus 1 is 28. So we've got 28.26 times by 10 gives us 282.6 centimeters cubed. Now, these 3 types of volumes are expected for you to be able to do. We're expecting you to be able to do before you hit National 5. Basically, what this is leading to is an overall idea that was taught in National 4, which I know that most people tend to bypass if they're doing National 5 and 4th year. But the volume of a prism, any prism, whether it's a cylinder, triangular, cuboid, V is equal to area of the end times the height. Okay? So all I have to do then, let's say I tell you that the area equals 48 centimeters squared. And let's just say, I know this isn't to scale, but just for the benefit of you being able to work this out. Let's say that that height there is going to be 20 centimeters. So I know that the volume of this shape here is the same idea. Area of the end times the height is going to be 48 times 20, which when you're doing the calculator gives you 960 centimeters cubed. There are, again, loads of examples for you to try. Please try some for yourself. Make sure you're comfortable with working out the volume of any prism. Thanks.